classification involving three sets. If this is your first time visiting my channel, kindly click on the subscribe button, and if you find this video helpful, do well to share it out. So if you haven't watched my previous video on Venn diagram and notations, kindly pause this video right now and go back and watch the video. I will drop the link of the video in the description below. So this was actually my last video on Venn diagram and notations, but today I will be moving to classification involving three sets. This actually classification involving two sets. If you have a better understanding on classification involving two sets, then the one that involves three sets won't be difficult. Now, let's say I'm having 8 boxes here, and inside each boxes, I'm having my sets, set A, set B, and set C. So I'll be explaining the intersection and also the union and also the complement of three sets in this video. Now, at first, we have a box here. Then this box is known as what? This box is actually called universal sets. Yeah, exactly. It's called universal set, or you just represent as this. Exactly. So it is called universal set. So inside each box, right? I'm having my set. This belongs to set A. This circle belongs to set B, and this circle belongs to set C. So let's say, according to the first box, I have all these parts. All this part is what is shaded. Then what does that mean? Looking at it very well, this circle actually belongs to my set A, and this circle belongs to my set B. Likewise, this circle also belongs to my set C. But I'm having this in this part shaded. Then it shows that if you look at this part very well, all the three sets actually intersect each other at this point. So what does that mean? How am I going to name this? If they actually intersect at this point, it shows that the three sets actually have one or two elements in common. So the element is what actually serves as the intersection of the three sets. Now, in this case, I can simply call this one A intersection B intersection C. Exactly. So that's the point. The point that is shaded on this box is known as A intersection B intersection C. Then let's move to the second box here. Exactly. I'm having set A, B, and C, the same thing also as this. Then let's say this part is shaded like this. Yes? Then what does that mean? In this case, first thing you need to do is that you are going to check each circle. If you check this circle is actually involved in the part shaded. This circle is also involved in the part shaded. Then this circle is not involved at all. So in that case, in that scenario actually, this part that is not involved is known as B complement. That is, B is not part of the intersection of A and C. Looking at this point that is shaded, it shows us there are some elements that actually belongs to set A, also that belongs to set C. So in this case, I can simply call this A intersection C intersection B complement. Exactly. Or you simply call it A intersection B complement intersection C. They are almost the same thing. They are the same thing. So let's move to the third box here. So the third box that I'm having here, let's say I have this part. Let's say I have this part. This part is shaded. Exactly. This part is shaded. So what does that mean? The case is almost the same thing as this case here, because if you check each circle, circle A is involved, circle B is also involved, but circle C is not involved, right? So it means it's the intersection is in between my set A and also set B. So in this case, I can just write as A intersection B, right? Intersection C complement, because it doesn't involve my C. Then let's move to the fourth box here. This fourth box, let's say I only have this part. This part is shaded, exactly. So if you look at the part shaded, it's in between my C and also what? B. In between circle B and circle C. Circle A is not involved. So I can simply say this is actually A complement intersection B intersection C. That means A is not involved at all. So let's move to the fifth box rather. So let's say I'm just having only this part. Only this part, exactly. This part is actually, let's say I'm having only this part. If you look at this very well, actually, shading all this part, it shows that all this intersection, all these four intersection is actually not involved in the part shaded. So looking at this, my set B is all alone, my set C is all alone. So I can just go ahead and say this is actually the same as writing A intersection B complement intersection C complement. So that's the part that is shaded. So another thing that I can say here is that if you're looking at this part that was shaded, this part actually means A only. It doesn't involve the intersection. It means A only. I'm not talking about this A. Exactly. This A represents all the elements that are in this circle, including those of the intercept. So everything here like this is actually this A. But inside everything here, we have A only. That is the part that doesn't involve other sets. So let's move to the sixth box I'm having here. So the sixth box, let's say I'm having the case of my A, B, and C. This part was shaded. Exactly, this part is shaded. So let's see. Looking at this is actually B. It's still the same thing as this case, but in this case, I'm going to put it like A complement intersection B, exactly, intersection C complement. So that's just the case I can have here. Then let's move to the seventh box. Let's say I'm having a part of C here by shaded. Exactly. This part is shaded. So what's going to be this? It's still the same thing as this, but in this case, I'm talking about C only. So here I'm going to have it to be A complement intersection B complement intersection C. Exactly. So the last box I'm having here, let me just say all the parts here, everything here was actually shaded. Exactly. Everything here was shaded. Exactly. You have this part shaded, everything here shaded, exactly. So what does that mean? If everything was shaded, that means we are talking about the parts that are not even involved in the sets, or let me just say the parts that are not even involved, that are not involved whenever we are trying to sum all the sets together, which is our universal set. So in this case now, this is going to represent universal complement. Or you say the union of set A, set B, and set C complement. So here I'm going to have it to be A complement intersection, or let me just intersection B complement intersection C complement. I can have it like this, or I simply say A union B union C complement, or you call this prime. This is actually prime, or you simply say complement. So this part that is shaded is actually the you call it here A union B union C complement. And don't forget that talking about universal sets equals to what? Equals to A union B union C, right? Plus what? Plus A union B union C complement. Exactly. So this A union B union C complement is the part that we are talking about now. So, alright, if you find this video helpful, kindly click on the subscribe button and do where to visit my channel by clicking on clicking the notification button so that you get notified whenever I drop another video. Do well to share this video with your friends if you find it helpful. Thanks for watching.